Good evening, friends. Today we will talk about recursive function. A function that call itself is known as recursive function. Still now we have written so many functions in modular programming, but we are not calling a function again and again. Such a function is called recursive function. Let's see an example. It's a rebuild function is being written. This main is been calling the rebuild function. This rebuild function, we can see that it's been calling itself. So we can consider this rebuild function as a recursive function. So this rebuild function is been calling itself. Let's see. Let's go through this. Here the main function called the rebuild function, and the rebuild function is again calling itself. So the rebuild function is a recursive function. If we examine the rebuild function, we can see that the rebuild function has been calling infinite number of times. It is not breaking, it has been calling again and again. So this rebuild function is an infinite calling function. Infinite number of times it has been calling. But in the real case, we will avoid this infinite number of calling by a recursive function by using an if-else statements. To prevent infinite recursion, if-else statement can be used where one branch make the recursive call and other does not. So we will use conditions to call whether we want to call a recursive function again or not. We will decide based on the if-else statement. Let's see an example. This function is finding the factorial of a number. You know the factorial of a number is, for example, 5. I want to find the factorial of 5. 5 is 5 into 4 into 3 into 2 into 1. That's a factorial of a number. That operation is performed by this function. So it's saying that if the number is less than or equal to 1, it should break, return 1. It's not calling the function again. Otherwise, this function has been calling. Again, this function has been calling itself. So we have avoided the infinite loop case of the recursive function using this if-else statements like this. Let's see what is the output of this function. Okay, and I want to find out the factorial of 5. So factorial of 5 is being called. So factorial of 5 is less than or equal to 1 statement is wrong. So else statement will be executed. So else statement is saying 5 into factorial of 4 will be called. Factorial of 4 should be called. That means the factorial of 5 program should be terminated, should be stopped now at present. Normally the function will be stopped after completing the operation, but here we want to stop that so that its information will be stored in the memory and factorial of 4 will be called. Okay, factorial of 4 is been called. Factorial of 4 is 4 is a checking, number is 4. 4 is less than or equal to 1 statement is wrong. So we will go for the else statement. 4 into factorial of 3 is been called. Okay, again this function has been calling another factorial function. So the program factorial of 4 should be stopped now and factorial of 3 will be executed. Factorial of 3 has been executed. So factorial of 3 started executing. 3 is greater than or equal to 1. So else statement should be executed. So again 3 into factorial of 2 should be performed. Okay, factorial of 2 should be performed. Factorial of 2, that means factorial of 3 should be stopped and factorial of 2 is being called. Factorial of 2 is executed. Again 2 is greater than or equal to 1. So else statement will be executed. 2 into factorial of 1 will be executed. Okay, so factorial of 2 will be stopped and factorial of 1 will be called. Okay, factorial of 1 is less than or equal to 1. The statement, if statement is true at first time. So it will go to the if statement and it will say that it is returning 1. 1 will be returned. Actually factorial of 1 is being called by factorial of 2. So that means factorial of 1 result will be passed to factorial of 2. So 1 is being passed to 2. 2 program stopped at the statement return 2 into factorial of 1. So it will be executed. Factorial of 1 is 1. So we will get 2 into 1. That the result will be 2 will be returned. So this is 2 is the result of factorial of 2. Then factorial of 2 is completed, but factorial of 3 is calling factorial 2. So the value of the factorial of 2 will be returned to factorial of 3. So factorial of 3 program stops at return 3 into factorial of 2. So 3 into factorial of 2 is 2. So 3 into 2 will be executed. We will get 6 as the return value. 6 is our value. Result is being executed as 6. So program factorial of 3 has been completed, but this factorial of 3 has been called by factorial of 4 now. So factorial to factorial of 4, the 6 will be passed. So the program factorial of 4 stopped at return 4 into factorial of 3. So it will start executing. Factorial of 3 is 6, so it will be replaced there. So it becomes 4 into 6. 4, 6, 4, so 24 will be returned. So factorial of 4 completed. But problem is that factorial of 4 has been called by factorial of 5. So 24 should be returned back to factorial of 5. So factorial of 5 stopped at 5 into factorial of 4. So 5 into factorial of 4. Factorial of 4 is 24. 24 into 5 will be executed. So we will get a return of 120. This factorial of 5 has been called by main. So main will get an answer as 120. This is the operation of the program. This is a very simple program. It's been calling again and again until factorial of 1. When factorial of 1 reaches, we'll have an answer. It will return back the information. In this way, it will be executing the program. This is a factorial program. I think it's clear. Recursive function is a function that is calling itself. Let's see another example. Okay, sum of natural numbers. I want to calculate the sum of natural numbers. I'm giving it as 5. Then I should return 1 plus 2 plus 3 plus 4 plus 5. That should be the answer. So what the program do? If n is less than or equal to 0, return n. That is factorial is, if it is less than or number is less than or equal to 0, it should return that number. Otherwise, it should return n plus sum of n minus 1. Sum of n minus 1, it should return. Let's see, we have two statements. One if statement is there, true is there. In true statement, program is been stopping. In the false statement, the function is been calling again and again. So this function, as the function is calling again and again, this function can be considered is a recursive function. Okay, so let's see the example. So sum of 5 I want to calculate. 5 is less than or equal to 0 statement is wrong. So else statement will be executed. 5 plus sum of 4 will be called. Sum of 4 will be called. Again, sum of 5 will be stopped there. Sum of 4 started executing. 4 is less than or equal to 0 is wrong statement. So again, statement will be executed. 4 plus sum of 3 will be executed. Then sum of 3 will be called. Then 3 plus sum of 2 will be called. Then 2 again 2 plus sum of 1 will be called. So again 1 plus sum of 0. Sum of 0, we have the return value, we have the statement. This if statement will be executed, and if 0 is less than or equal to 0, so it will return 0. So 0 will be replaced, 0 will be stored here. 0 plus 1, 1 will be here, 1 will be passed to here. 2 plus 1 is 3. 3 is being passed here. 3 plus 3 is 6. 6 is passed here. 6 plus 4, 10. 10 is passed here. 10 plus 5, 15. So we will get the return value as 50. This is a program of sum of natural numbers. See, I think it's clear. Very simple program. Next one, Fibonacci series. What is Fibonacci series? Fibonacci series is a series of sequence where the first two numbers, if we add the first two numbers, we will get the third number. So before seeing the program, we will see the example. Example of Fibonacci series is 0, 1, 1, 2, 3, 5, etc. That means if 0 and 1 is added, we will get 1. 1 plus 1 is added, 2 will be getted. 1 plus 2 will 3. 3 plus 2 is 5. Next will be 3 plus 5, 8. Like that, the series will go. That is sum of first two numbers is the third number. That's the main logic of Fibonacci series. So we want to generate the Fibonacci series. So 0 plus 1 will be 1, 1 plus 1 will be 2, 1 plus 2 will be 3, 2 plus 3 will be 5. Like that the series should be performed. The first two numbers are constant, remaining numbers we want to calculate. Okay. So let's see the example. So in the program Fibonacci series, if I equal to 0, then it should return 0, first number. The count, I'm actually generating the Fibonacci number. If I'm saying okay, this program is actually generating the Fibonacci number at the position, okay, I want to generate Fibonacci number at position 4. Position 4 Fibonacci number is 2. So if you call the function, this function will not generate the series, but it will generate the Fibonacci number at that particular position. Fibonacci number at 5 is 1, 2, 3, 4, 5. 5 is 3. It should return 3. That's the answer. Okay. So if the count is 0, first position is 0, then the value is 0, return 0. So you will get the first value 0. If the count is 1, if the second position is been asked, then it should return 1. These two are constants. Otherwise, if the question is I want to generate the Fibonacci series of 3, 1, 2, 3, third position I want to generate. If it's 0, 1, then second position I want to generate. This position I want to generate the Fibonacci series. Then it will again call Fibonacci of I minus 1 plus Fibonacci of I minus 2. That's the operation we want to perform. That is Fibonacci. If I want to generate Fibonacci of 2, 2 is not equal to 0, 2 is not equal to 1, then Fibonacci of, this statement should be executed. The statement is Fibonacci of 2 minus 1, it's 1. Fibonacci of 1 plus Fibonacci of 0. Fibonacci of 1 is been called. Fibonacci of 1 is 1. So this will be 1, and Fibonacci of 2 is Fibonacci of I minus 2 is 0. So Fibonacci of 0 is 0. So 1 plus 0, that answer will be 1. So next value, this operation has been performed, 1. Next we will take the next element. I want to generate the Fibonacci of this position, 0, 1, 2, 3. Third position I want to generate this one. So I want to generate the Fibonacci of 3. Okay, I want to generate the Fibonacci of 3. Fibonacci of 3. 3 is equal to 0? No. 3 is equal to 1? No. Then it should execute Fibonacci of 2 plus Fibonacci of 1. 2. Fibonacci of 2 will be executed. Fibonacci of 2 reaches. Okay, the program should be stopped here and Fibonacci of 2 is executed. Fibonacci of 2 is again Fibonacci of 0. Fibonacci of 1 plus Fibonacci of 0. So Fibonacci of 1 plus 0 again. 1 will be again called. Fibonacci of 1 returns 1. Fibonacci of 0 will be returned 0. So it will be returned as 1. That we have already calculated. Then Fibonacci of 2 is being calculated. That is actual value. This value. Fibonacci of 2 is been calculated. Fibonacci of 1 will be calculated. So the answer will be 2. Like that it will be executed. 1 plus 1. The answer will be. You can check that directly. Okay. So in the recursive function, we are passing the position and the function returns the Fibonacci number in that position. Fibonacci of 4, then it should generate 3. We can generate the Fibonacci series. Now I want to generate the Fibonacci series using the same function. I want to call it, but I don't want to generate the Fibonacci number at particular position. I want to generate the Fibonacci series itself. Then I will just write I will again call this function. The main function will not call once, it will call like this. This for loop will be written in the main program. So I will be calling I equal to 0, I is less than 4, I plus plus, I of 0. First I will call Fibonacci of 0. It will return it as 0. Then it will call Fibonacci of 1. That will return 1. Fibonacci of 2. It will generate 1 again. Fibonacci of 3. It will generate 2. Fibonacci of 4. It will generate 3 in the next value 3. So like that we can generate the Fibonacci series also using the same program. So this is the logic. So Fibonacci series we can generate. Fibonacci number is being generated using the recursive function, and we can modify the recursive function so that it will generate the Fibonacci series also. I think it's clear. Okay, so this is a recursive function, a function we are calling again and again. So what's the advantage of recursive function? It's more elegant and require lesser number of variables, which make the program short and clean. You can find out that program is very small. Recursive functions are very small, not that big. Uh, so that's the main advantage. Can be made to replace complex nesting codes, since we don't have to call the program and again to do the same task as it's called itself. So we normally if we want to call a function here, this Fibonacci number is been calling again and again using the for loop. We don't want such things in the recursive function. It is calling again itself. So that's another advantage. We can remove the nested for loops also. All the for loops can be removed by calling these functions. That's the advantage of recursive functions. So disadvantage, you require extra storage space. The recursive call and the automatic variables are stored in the stack. What is the stack? It's just a memory location where actually when we are calling, we have seen the example. This example, sum function. Okay, I want to perform sum of 5. The sum of 5 will be calculated at this particular point. The program should stop. You have to wait. The program will be stopped in this position because it is not completed. The program should restart again. That means all the information should be stored somewhere. So it will be stored in the memory. That memory is called stack. It's a special type of memory where the information are stored in last in first out model. What is meant by last in first out? Means if I am inserting something, first element, I inserted 4 elements. First I inserted 1, or suppose I am inserting four variables. First I inserted A, next I inserted B, next I inserted C, next I inserted D. If I want to remove, if I want to remove A, I should first remove D, C, B, then only I can remove A. So it will be removed in first out order. That is a stack. So so we have to use the stack in a recursive function. That's the main disadvantage. So it will sometimes it will slow down the process because we have to store all the information in the stack. We have to get it back. So it's time consuming. So that's the main disadvantage of a recursive program. It is comparatively difficult to think of the logic of the recursive function. We are being calling. We are not writing any for loops or looping. If we see the loop, okay, it's clear. We are being calling the function. Here we are not using the loops. Instead of that, the function has been calling itself. So there's a chance of having some confusion in the recursive function, but it's very useful. You will be studying stack later more. So just understand it's a memory where the informations are being stored, and it is using a last in first out technique. So elements will be removed according to the order as last in first out. You can see the example in this program itself. We are inserting sum of 5 will be inserting sum of 4, sum of 4 will be inserting sum of 3, sum of 2 will be inserting, then sum of 1 will be inserting, then sum of 0 we get the answer, but sum of 0 is actually calling sum of 1. That is being inserted last. That sum of 1 is calling sum of 2. So it's using the stack to, the recursive function is using the stack to perform this. So that's the main disadvantage. We will be using this recursive program when we have to write some large programs, because the size of the program can be reduced large. So simply in one word we can say a recursive function is a function that calls itself. Okay. Thank you very much. Enjoy every moment of your life.